Say again? I'm pretty sure you passed. We're not gonna, yeah, get on them, Piper. All right. It is a Friday, so I'm going to apologize and say I just made a big deal about you got to bring your calculator to class. It's a Friday. I might run out of time, right? Monday is when we literally will be doing homework with the calculator. Today, if you have your calculator, we can check our homework with the calculator. Okay. All right, here we go. So there's nothing to hand out. The worksheets, I gave you the option of either turning them in on Teams. A couple people said, hey, do I bring it to class? Do I turn it on Teams? And I said, either one, it's fine. If you have the homework, right, then in the class will say right here. All right, here we go. This is an algebraically challenging chapter. It is not challenging of what to do. You will know what to do. But it is a challenging test, challenging chapter, because a lot of it is, I'm doing it by hand. Like, wait a minute, you said bring a calculator. Yeah, we're going to use the calculator to check our work every day. Okay? The test that uses the calculator, you can do what? Hurry up. But I'm going to say, every single day, you're not bringing your calculator to class, it's a bad thing. We probably won't get to this entire sheet, but we'll get to much of it. We're going to do something that you remember from last year. Last year, this was the most painful thing that you did in course 2. This was the most painful thing. In fact, if you had me as an instructor, I called this literally the table of pain. Okay, and then if you were paying attention last year, I said that when you get to Algebra 1, I'm going to show you the easy way to do it. Hey, listen, please. We're at that day. So there are way easier ways of doing what we did last year, this thing, than how we did it last year. So why do math teachers make you do it the more challenging way first? The more challenging way applies throughout all of math. We can use that method of doing this thing called a table of values, table of pain, to do this thing. All right, homework right now. Monday is when you must do this on a calculator. Today, if we have time, I'm going to show you how to do this on the calculator. Most likely we will run out of time because it's Friday. Yeah. Okay, let's do this first. The expectation for today's homework is you're doing the whole thing by hand. You use a calculator to check your work. As we do these problems throughout the chapter, each day, we're going to be using our calculators to check our work, to make sure we got the right answer. And the reason we need a calculator to do this, because you'll see this is going to be a really challenging thing to do without a calculator to check it. All right, here we go. Last year, this was the thing that most of you probably didn't like to do because it required at least 5 minutes of work to get to one answer. Okay? It was called systems of equations. So let me explain what you did last year. Last chapter, we did this thing called linear equations. I gave you an equation, and I said, graph this sucker. Okay? Well, graph this sucker. What's the slope? Y-intercept here? 1. It's 1. So we put a dot on 1. What's the slope? We go up 2 over 1, up 2 over 1, and we make that line. Okay? Okay? This was last chapter. Okay? Last chapter, we also start off by saying, why is it called a linear equation? It's because any solution to this equation, here's 1 at 0, 1. Any solution, 2 times 0 plus 1 is 1. Any solution is on this red line. In fact, 0, 1 is the y-intercept. Right? Here's another solution, 2, 5. What's 2 times 2? Plus 1. There's another solution. 2, 5 is on that line. These are all solutions that live on that line. All the solutions put together make this red line. That's what we did last chapter. Okay? All solutions to that equation make the red part. This chapter, well, I'm going to give you a linear equation. That's the same one we just did. Okay, great. But I'm going to give you a second one. And I'm going to say, what is the solution to the system of equations? In other words, it's not one equation, it's multiple equations. No, I'm not going to give you 3. That's later on, pre-calculus. But I'm going to give you 2 equations and say, what's the solution to this? Well, let's think about this. Solutions are things that make the line from the previous one. So if I say, what is the solution to the system of equations? Well, there's 2x plus 1. Here's 4x minus 1, and what do you notice? They meet in how many points? 1. So all the solutions to this, it's supposed to be red, it doesn't look red. All the solutions to the red one, which is this one right here, live on that line. There, that point right there lives on the line, that point lives on the line, that point lives on the line, that point lives on the line. On the blue one right here, it's supposed to be blue, it kind of looks blue. There's solutions, there's one, there's another one. All those are solutions to it. But there's only one point, that one right there, that actually lives on both lines. So the punchline to what is the solution to a system of equation is, what is the one point that lives on both lines? We're going to spend an entire chapter on this. I give you 2 lines, you tell me where they intersect. Okay, you did this last year. How many people do not remember doing this last year? Okay, didn't teach. Throwing things at you, right? But most of the people that rose their hand, well, maybe you didn't learn it last year. In our book, we learned this last year. In our book, the way that we did this was we made a table of values for each line. We came up with 4 points. We applied the 4 points. We played connect the dots. We applied the second one, and we found where they intersect. Okay, so it turns out that there's an easier way of doing it, and that's because now we know that y equals mx plus b. We can graph these lines quickly. Okay, all right. So the solution to that is the point where the 2 lines intersect. They intersect at 1, 3. And check it out. What's 2 times 1? 2 times 1 plus 1. Second equation. What's 4 times 1? Minus 1. It is the only point that makes both of these equations true. It's the only point. Any other point on either one of the lines will make one of the equations true, but the other one false. But there is one point, 1, 3, that makes both of them true. That's the whole chapter right there. Like, why do I need a chapter for that? I just did it. Yeah, that's a good question. I will answer that as we move on through the chapter. Why we need an entire chapter to teach this when I literally just taught it to you. All right, recall this. Last year we did 2 tables. 1 table for the red line, 1 table for the blue line. It was painful. 5 minutes. This is called solving the system by graphing. We literally make a graph and we visually identify where the 2 lines intersect. Well, it turns out there are other methods. Okay, it turns out there are other methods to do this other than graphing. There's 2 other methods. They're not done graphing, they're done with algebra. Okay. So to find a system of 2 linear equations, well, one way is your graph. Okay, great. We find the intersection until we come to a problem like this. I just graphed them both. What's the problem? Well, I can see where they intersect. Can you see it? What's that point? Well, it's a point, but it doesn't fall on a lattice point. This is why you have a graphing calculator in front of you. Your calculator will tell you the answer to this. If you type in both of these equations into your graphing calculator and say, calculator, give me the answer. It will do it like that if you know the right buttons to press. And I will show you that Monday. Okay. Today, we're going to do all the ones where it looks like this, where they intersect perfectly at a lattice point. But that doesn't happen all the time. Lines can intersect not at a lattice point. So we need other techniques. Well, the first technique is I use a calculator, tried and true. If you got a calculator, this thing will do it in, well, it takes however long it takes you to type in the 2 equations and press the 1 button it takes to find the answer. Really quickly, right? Well, if you don't have a graphing calculator, we got to do it by hand. We have to do what your graphing calculator is doing by hand. And that turns out to be two techniques. One is called substitution, and one is called elimination. So why is this a whole chapter on this? Because sometimes the lines don't intersect at a lattice point. Okay? If they don't intersect at a lattice, and by the way, you can't tell if they will or will not intersect at a lattice point until you do the problem. You don't want to do this whole thing by hand to find out they don't intersect at the lattice point and then have to pick substitution or elimination. So why two more techniques? Why can't we just have one? It depends what the equations visually look like. For some of the equations, it's quicker to use substitution. For other equations, it's quicker to use elimination. Every student loves elimination. Every student hates substitution. Every student loves graphing because you're using your graphing calculator. So I like number one. I like number three. Nobody likes number two. Guess which one we'll spend the most time on? Number two, because it's the hardest one to do. Right? It's also, and I mean hard by mean it's got the most work involved. Elimination is sweet, but you only use elimination if your equations look a certain way. All right, so that's in the broad general terms of what we're doing. Today, we're going to do it all by hand. They're all going to intersect at nice, friendly points. It's going to be an easy day. Graphing to find the intersection was last year. Algebra 1 is substitution elimination. When you took the NWEA test, you had a couple of these, and it said solve by substitution or solve by elimination. You guys had no clue what you were doing because it wasn't taught to you. All right, so today we're going to do this one. Monday, we will use the calculator to do this. Like today, we're literally going to graph, we're going to find where they intersect. And then on Monday, I will teach you how to use this. If I have time, which I'm already talking too long right now, I'd show you today how you can check. All right, so here we go. In order to do this by hand, obviously, you got to be neat and precise. You cannot use your hand to like draw a line. You got to use a straight edge. It's got to be nice and straight when you draw your lines. If your lines go off at an angle when they're supposed to be straight, then you don't get the right answer. Graph paper certainly helps out. It's not a requirement. Boy, do you have to be neat if you don't have graph paper. So I'm just going to say, do this on graph paper tonight. With a graphing calculator, you can find the answer in about 10 seconds. Doing it by hand might take you about 30 seconds. It's not like last year, which was 5 minutes. So don't panic. All right, so let's do this. Box one, grab your pencils. Here we go. You just had a test. In fact, you just had a day of practicing graphing lines. That's why you have to practice it because of today. So here we go. It doesn't matter which line you do first. Now, make sure you follow my instructions. Don't make a line yet. Nathan, what's the y-intercept of the first one? What's the y-intercept of the first one? What is it? It's 2. Put a dot on y value 2. Boom. Porter, what's the slope of the first line? What is it? The first one. That's the top one. 1 over 1. Now notice he didn't say 1. He said 1 over 1 because he knows I need rise over run. If it's not a fraction, make it a fraction. So from your dot, you're going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. See what I did? How many dots will you need? I can't give you an answer to that. Well, let's hold off on a lot. If you're lucky, you're going to find out immediately where the two lines intersect. If you're not lucky, then you're going to be putting a lot of dots. If you go in the other direction, what do I do, Chris? Down 1 over 1, down 1 over 1, down 1 over 1. So I put 1, 2, 3, 4, 5, 6, 7, 8 dots on it. Okay. There's not an answer to how many dots. I would not fill up the whole thing full of dots. The first line that you graph, though, put a lot of dots. Okay. Let's graph the second one. When we graph the second one, we are looking to see where the two lines intersect. As soon as you find that out, guess what? You're done. You don't actually have to draw the lines. You're just looking to see where the two lines intersect. That's the answer. Okay? So, Chris, what's the y-intercept of the second line? 1. Where do you see that? Where's the second equation?
Sorry, right there.
It's blue. So what's the y-intercept? That's the slope. What's the y-intercept? And don't listen to him, he's wrong too.
I don't know.
It's this number right here.
Oh, right.
Y equals mx, y equals mx plus b. So what's the y-intercept? So put a dot on -2. Chris, what's the slope? X is not a slope. X is x. Okay, but we like it as a fraction, so therefore we write that's the rise and the run. So from my dot right here, we're going to do what? Up 3/1. Watch me. Up 1, 2, 3/1. Did they intersect? Not yet. Go up 3/1. 1, 2, 3/1. And guess what? You're done. You literally got a point that was on the other line. Does everyone see what I just did there? E-learners, +2 on the yellow one. Up 1/1. Up 1/1. Up 1/1. Or down 1/1. The second one, the y-intercept is -2. Up 3/1. Up 3. Oh, look, it's the same dots. When I go up 3/1, I get to the same dot. That's the answer. Yes, the book would like you to make nice, pretty lines. Who cares? The lines aren't part of the answer. It's where they intersect. As soon as you identify where they intersect, name that point. I don't mean like A, B, C. I mean, what are the coordinates of that point? What are the coordinates of that point? And that's your answer. Check it out. What's 2 plus 2? What's 3 times 2? 3 times 2? -2. You found the point that makes both of them true. Rowan, you've never done this before? Or does this sound familiar now? You never did this before? Or does it sound familiar now? Yeah. Okay, that's fine. Okay, that's what we're doing today. By the way, this is how long it takes to do it on your calculator. I'll show it to you on Monday. One button, x plus 2. Second one, 3x minus 2. Graph. Calculate. And what's it say at the very bottom? Very bottom. Okay. I haven't done this for a while. What's it say at the bottom?
X equals 2, y equals 4.
All right, I'm going to claim that I can do that a lot quicker, but I guess I should have practiced that. It's about 30 seconds to get to an answer, right? Not much longer. Okay, here we go. The rest of the class is just practicing this. That's it, just practicing. The check step would be literally throw 2, 4 into both of them and make sure you do, in fact, get the same answer we did. All right, box 2, here we go. Tristan, what's the y-intercept of the first one? 2. Put a dot on 2. What's the slope? Nathan? And we like it as a friend. 1 is a right answer, but we know what we're about to do, so we usually say 1/1. So from that, I'm going to go up 1/1, up 1/1. How many dots do you put? I don't know, right? Some people put 2 dots and they stop because they're like, well, I'm not going to put too many dots. I don't even know where they're going to intersect. Let me graph the second one, and that'll kind of give me a feel for it. Okay? But if you were to go in the other direction, then down 1/1. All right, Nathan, y-intercept of the second one. So I put a dot on +4. I mean, clearly you can see, well, if they intersect, it's going to be below the red dot, right? It can't be above it. Aiden, what's the slope of the second line? 2/1, right? Because we like it as a, now 2 is the right answer, by the way. But since we're about to apply it here, now watch this, everybody. If we go up 2/1, what just happened? Are we getting closer or farther away from the intersection point? So I don't need to continue in that direction because I know it's not going to intersect. So I need to go in the other direction. So I need to go down 2/1. Did we get an intersection yet? So maybe one more time. Down 2/1. Oh, they still didn't. But wait a minute. How about if we extend the blue line? What was the slope of the blue line? Up 1/1. If we go in the other direction, it would be down 1/1. Did they intersect? One more time. You're done. Once again, the book, if you open up your book, it's going to show you graph and lines. I always leave minus dots. Right? If it says solve by graphing and it doesn't say use a graphing calculator, they're going to intersect at a lattice point. They're going to intersect at a lattice point. -2, 0 is what makes both of these true. -2 plus 2 is 0. 2 times -2 is -4. -4 plus 4 is 0. Boom, done. After you do a few of these, you're going to be wondering why you got last chapter test so wrong. Some of you, not all of you. Because it forces you to graph 2 lines on one graph. Yeah. Sure it is. Remember, it goes x comma y, right? This is your x, this is your y. So I go over -2 and then up and down 0. That's right there. Yes? Okay. This is 0, -2. Common mistake. Okay. And I did the check step is optional. I'm just throwing both the point into both equations to see if it makes it true. All right. Box number 3. Ari, first. Oops. I think I had this one to do it by hand. All right. Watch me do it by hand. All right. If you are really neat, you can make this work. But boy, you have to be neat. Y-intercept with the first one. -1. So I put a dot on -1. Slope. So up 2 over 1. I got to be really neat. Up 2 over 1. I'm going to just put that first dot and I'm going to stop. The more I do, probably the less accurate I am. So I'm going to stop on my first stop. Second one. Oh, geez, boy, that's way below. 2, 3, 4, 5, 6, 7. What's the slope? Up 4 over 1. So up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. Okay, so it's probably going to be the next dot, but let's see what happens. So this one right here, which is about like that, we got to go up 1, 2 over 1. Well, that's not going to be up 4. Up 1, 2 over another 1. And that's it right there. So up 1, 2, 3, 4 over 1. There you go. Hard to do by hand, right? It's a big honking mess. Don't do it by hand. Use graph paper. Graph paper. Graph paper makes your life a whole lot easier. Plus, you can read your final answer. 3, 5. Let's see. 2 times 3 is 6. 6 minus 1 is 5. 4 times 3 is 12. 12 minus 7 is 5. There's your answer. All right, who's lost? No one is lost? Really? Well, either I'm doing a good job or it's Friday and no one's listening. One of the two. Rylan? Yes?
Yep.
Okay. Yeah, and the other thing too is when this chapter follows immediately the previous chapter, nobody generally is too lost on this. It's just graphing 2 lines. Can you make a mistake? Oh, absolutely, right? And it's one of those normal mistakes. You graph the y-intercept incorrectly. You apply the slope incorrectly. But the idea, we're going to skip the real world problem. It's kind of an interesting thing, but it just gives you 2 scenarios that are linear. You find that the 2 lines intersect, and where they intersect is where their 2 alligators are the same size. The last thing is the more important thing. All right, look at me. I got 2 lines, number 1, number 2. Okay, you ready? 2 lines can intersect, right, when you draw them. There's 2 other things that can happen if you draw 2 lines. They can intersect, or if they're parallel, how many places do they intersect? So when you do this tonight for homework and you find out you have parallel lines, guess what the answer is? There's no answer.
No solution.
No solution. There's one weird one that can happen. You're not going to see it tonight for homework, but it could literally be the same line, just in different forms. How many times do they touch? So how many solutions? Infinite solutions. Do you remember this from last year? Okay. When the 2 lines are the same, there's infinite solutions. They're the same line. They touch infinite number of spots, right? They can either touch 1, none, or every one. All right. Write that somewhere down just so that you have that in front of you. But what is that going to look like when we actually do it? And this is basically what this slide says. If they are, this is the one that like, well, why would you not notice that you're graphing the same line? It's true until we get to substitution or elimination. If I give you two lines, y equals 3x plus 1, y equals 3x plus 1, you're going to know from the start that they're the same line. We get to the substitution and elimination ones, you're not going to know. They will visually not look alike, but they will be the same. You're like, what? How could that happen? Well, somebody give me a line. Y equals what? 5x what? Plus 7. Multiply everything by 2.
10.
I get 2y is equal to 10x plus 14. Here are two exactly the same lines. If you graph both of these lines, they're the same line. You just will not notice that, oh, wait, it's the same line. Okay? That's how the infinite solution. That's usually kids are like, how would that ever happen? It's a math teacher messing with you. Okay, so one solution, no solution, infinite solution. If the two lines intersect, one spot, we say there's one solution. If they're parallel, there's no solution. We can go a little bit further with this since we're Algebra 1. Check this out. From last chapter, what do we know about slopes of parallel lines? Slopes of parallel lines. Nope, unless they're vertical. What are the slopes of parallel lines? They are the same. So you can, if you're on the ball, you can visually tell that you got parallel lines if the number attached to x is the same number. But you got to be on the ball for infinite or for Algebra 1. So if there's one solution, the slopes will not be the same. Okay? The slopes must be different for them to intersect. Okay? So visually looking at them, check it out. Are you paying attention? Riley's sleeping. All right, Riley, head up. Come on. If there's one solution, check it out. The number attached to x will be different. The question tonight for homework will say how many solutions. Look at what numbers attached to x. If they're different, one solution. If they're parallel, well, that means the slopes will be the same, right? The number attached to x will be the same, but they're not the same equations. They're slightly different. Notice the y-intercepts are different. So when they're parallel lines, the slopes will be exactly the same. What will be different are the y-intercepts. If you don't know this, guess what you have to do? But if you can't remember this, guess what you have to do? You got to graph it. And like, oh, look, they're parallel lines. Silly me, right? But if you notice right from the start, and it says how many solutions, well, different slopes, one solution. Same slopes, different y-intercepts, no solutions. Lastly, if they are the same line, well, the slopes have to be the same, and so does the y-intercept have to be the same. I mean, it literally will have to be the same equation. The example I showed you, I just multiplied everything by 2. Well, then if I divide everything by 2, I get back to the same equation. There's only a few questions like this tonight for homework. It'll say, state whether there's one, none, or infinite solutions. Okay, if you want to do it the hard way, graph the lines. If you want to do it the easy way, this is the thing you have to remember. Questions? You got about 5 minutes left. We're perfectly on time. Crazy, I thought it was going to take longer. You want to do this with your calculators now?
Yeah.
All right, grab your calculators.
Can I go get my calculator?
I'm not sending people, the entire class, to go get your calculators.
Right.
No, you're the 5th person during class. Rowan was the 4th person. All right. Here we go. Grab your calculators. Let's do, which is the first one we did that we got to an answer to? Let's do the very first one. By the way, what was the answer to the very first one, box 1? I thought it was 2-4. 2-4, right? Okay, so we're doing box 1. We already know the answer is 2-4. So let's see how this works. Now, usually the first time we do this, there's always going to be, 1 or 2 kids that gets lost. It's okay. Don't panic. We got plenty of time. Oh, I'll just go ahead and show you the answer. We better get 2-4 as the answer. You ready? All right, step number 1. On your graphing calculator, on the upper right side, the very top key, I'm sorry, upper left side is called, it's called y equals. Press that button. Okay, now if I've messed with your calculator, which I have, You're going to have stuff written on it. Who's got stuff written on it? Okay. Right side, clear button. Scroll to where it has something written and hit the clear button so that you have a perfectly clear space. Hey, get your calculator out. Let's go. Oh, it's dead? Sorry. Does everyone have a clear screen now? All right, we're going to type both equations in. Okay. The first line on there, it literally says, y1. That means you can graph 1 line, 2 line, 3 line, 4 line. So y1 will be the first line. Okay. The blinkers or the cursor should be blinking after the equal sign. Yes, everybody? Okay. The X button, because we need to do X plus 2. The X button is right here. It's kind of the second one from the left, second button down. Right here. It says X on it. Press it once and you'll get an X. Sorry. Press it once and you'll get an X. Did everybody get an X? Right. Okay, now hit plus 2. Okay, first one's done, hit enter. Okay, now you're on the second one, yes? Type in 3x minus 2. We good? You don't have to press enter at this point. Okay, you ready for the magic?
No.
Upper right-hand button is called, it's called graph. Press that button. And magically, the 2 lines will now appear. And you can visually see that they intersect probably somewhere close to 2, 4. But we can go further. We can have it tell us exactly where that point is. You ready? Ready? Okay. Here's what you have to do. Above those top buttons right here are words. Some of the words are in blue. One of the words, second from the right, is calculate. In order to get the blue words, we hit the blue button. The blue button is far right. So hit the blue button and then calculate. You get a list of options. Guess which one we're going to pick? No? What are we trying to find? Where they intersect. So we're going to select intersection. You can either highlight it and hit enter. Second, calculate. Scroll down, or you can literally hit number 5. Enter. Enter. Okay. Now it's going to ask you a series of questions. It's going to say, well, which one is your first line? It doesn't matter. Hit enter again. It says, what is your second line? It doesn't matter. Hit enter again. It says, take a guess. Hit enter a third time. And what's it say now at the bottom? And there's your answer. Okay, that took me 2 minutes to explain. When you do this by hand, this is under 30 seconds. Okay? Let's do another one. All right. So box 2, we already know the answer is. We already know the answer is what? -2, All right, here we go. You hit the y equals button. Now you got stuff in there, so you got to either type over or clear it out. Either one's fine. So hit y equals. You can either hit the clear button or just type over it. The first equation is x plus 2. Second one is, scroll down. The second one is 2x plus 4. Okay, once that's done, you hit the magic graph button. It graphs the 2 lines. Once that's done, you hit the second button, calculate. You can hit the 5 or scroll down and hit enter. You got 1 more minute, or 2 more minutes. Okay. All right. And it says the answer is -20. Look at you. Graphing calculators are, they got all the answers. I need to show you how to use yours. You are here.
I might read.
Somebody, this is the first time. Someone And I was going to say, which one do you want in your first line? Don't put it right. It's actually which one, because sometimes you could have 3 lines you get wrong, and maybe you only want to do the first one. You hit enter again. And then it says take a guess, you hit enter. And it says, you never had this before? Really? Where were you last year? Or you were homeschooled?
I went to school one day a week at RMCA.
They do this. They have to.
Not,
In 8th grade?
I didn't do 8th grade there, and I did 7th grade and 8th grade at
7th grade doesn't.
And then, so I did the math course, Alex.
This is an Alex, absolutely. Alex isn't
but-
really it's an intervention course. No.
How do you
Yeah,
fix that?
but see, with the
I
class,
can't get that out.
I
Camera?
was-
Keep talking, I'm listening.
I was too far ahead. I did 3
That's
math
why they had you on
courses.
Alex. They were lazy, right?
So
You can take a pencil.
they did mostly fractions with like how to add and subtract.
How
them,
big is your finger?
And they never.
This big?
they
I'm
never
being
just-
rude, but so put this like this and then squeeze it together
They
and that'll
just
make it this right
never-
shape. Now squeeze it.
I just worked on my own, and they just worked at what everyone else in the class was. So
Yeah.
they told me to just ignore the class.
So Alex is made for kids that are struggling in math to help them get better at it. It's not made for to teach you math. It's made for, okay, well, they can't add or subtract your positive negative numbers. So you go do Alex and it'll walk you through those problems and help and stuff. It's not made to actually teach you. So
That's how they.
So what happened is that you were the smart kid and they're like, well, what are we going to do with her? I don't know. All right, just put her on the computer. Yeah, you'll be fine. Did it work? So when you squeeze it, it'll make it that dimension so it's nice and big and thick. Right? But maybe you need to use this because maybe it's. Okay, so now it's going to be that wide. So I know, put it in there, see if it hurts. If it doesn't, just get something thicker than that, and then. I was being rude. I'm sorry. Oh, and I'm even being more rude because the e-learners are listening to all this, and sorry, e-learners. Is there anyone live? No, there's no one live.